today I'm going to be going over a general mechanism of muscle contraction. So an alpha motor neuron enters the muscle and divides into several branches, each stimulating a muscle fiber. One alpha motor neuron, along with its muscle fibers that it's innervating, is considered one motor unit. The size of the motor unit usually correlates with the function of the muscle. So for example, the muscles in your eyes, the ones that control eye movement, those have smaller units, usually with only 3 to 5 muscle fibers, whereas muscles in your back or your legs that are a lot bigger, those have thousands of muscle fibers per unit. The more motor units involved, the greater the contraction is going to be. So I'm going to start with defining what a muscle twitch is. Oops. So when an action potential travels down the motor neuron and contracts those muscle fibers within that motor neuron, the response of one muscle fiber is essentially the muscle twitch. And with that response, we're going to have 3 different phases. So if you look at this graph here, we're going to have tension over time. And that single stimulus right here is going to be that action potential. So the first phase is the latent period. This is like the short delay, 1 to 2 milliseconds, where the action potential reaches the end of the motor neuron, and there's a depolarization of the motor plate, calcium binding to troponin, and all of that. The following after that, we're going to have the contraction period. And during the contraction period, this is when actin and myosin form and ATP is used. After the contraction period, we're going to have the relaxation period, which is the longest period. After this, calcium's transported back into the sarcoplasmic reticulum, and the muscle is going to lengthen because it's relaxing. So keep in mind, action potentials can't vary in the magnitude or speed in which they are released. But what we can change is the number of action potentials per second. Each action potential causes 1 unit of muscle contraction. So if we have that one muscle unit contracting and then we're building on it before it's had a full time to completely relax, we're going to be adding another action potential onto it. So that here is what we're going to have is called wave summation. So as I said, each action potential causes 1 unit of muscle contraction, and the muscle will relax as soon as that action potential is over. The excitation, contraction, coupling effects is going to be added to each other, which is why we're going to have a wave summation. The bottom of each wave, at the very bottom here, is where we're going to have that next action potential, and it's going to go on. We're going to have contraction and then relaxation. And then right there at the bottom, we're going to have another action potential. So it's going to keep adding onto each other. Now remember, I said that you can't change the speed or the magnitude. All you can change is the frequency. So when the action potential or the stimulus frequency is so high that the relaxation phase doesn't even have a chance to go down at all, where it's essentially going to disappear, which is what we have here. This is going to be our tetanus. And just to reiterate what I said, when the stimulus frequency is so high that the relaxation phase disappears completely because we don't see it relaxing at all here, with the tension is not going to be releasing, that's what we're going to have as tetanus. Now, when it comes to motor unit recruitment, generally motor units are recruited in order of their size. So when the muscle is first activated, we're going to have our slow or type 1 units, let's just put S, which will be first. They have the smallest force and the slowest contraction. After that, we're going to have FR, or fast resistant muscle fibers. Those are going to be a little bit of a larger force and a faster contraction time. And lastly, we're going to have FF, or fast, easily fatigable. These have a large force and a fast contraction. So that's the order of the motor unit recruitment. And then lastly, I just want to talk about two different types of muscle contractions. So over here, we're going to have isotonic. And isotonic can be broken down to two different types. There's eccentric and concentric. So concentric is like in this image where a muscle is activated and required to lift a load less than the maximum tension it can generate, resulting in a muscle shortening. Then there's eccentric, where the external force on that muscle is going to be greater than the maximal force. This is going to result in a muscle lengthening. So isotonic is when we have either a shortening or a lengthening of that muscle. And then over here in this image, we're going to have isometric. And isometric essentially when the muscle is activated at constant length. So there's still tension on the muscle, but the length of that muscle isn't going to be changing. Thanks for listening.